Here's a video discussing sections 1.6 and 1.7. There'll be an overview of what we'll talk about next time in class. So I won't do all these problems, but I'll probably do the first part of each example here. So 1.6 about solving linear inequalities, which is really just solving an equation. So for part A, when x is less than 2, you want to locate 2, but since 2 is not included, we put a circle that's not filled in. You're going to shade to the left because you want to include all numbers less than 2, like 1, 0, -1, -2. And of course, any decimals or fractions. So all real numbers less than 2. Greater means you go to the right. And if it's greater than or equal to or less than 2, you make sure your circle is filled in. And for C and D, we'll talk about in class, but if you're in between two numbers and you're going to shade in between 0 and 2, if you're going to the left of one number and to the right of another number, then your arrows will go in opposite directions. And those are called compound inequalities. So C and D are examples of that. And C is an example of an and situation because you're simultaneously greater than or equal to 0 and less than 2. So if I look at example 2, part A, we're simultaneously less than 2 and greater than 5. Actually, that can't happen. This is impossible. Because you can't simultaneously be less than -2 and greater than 5. So sure, I can shade that. Sure, I can shade that, but there's no overlap. So the and situation, there has to be an overlap or an intersection. And these clearly do not overlap. So this is impossible. Now, example 3 talks about the or situation. I'll give you less than 0 or less than 4. So it's one or the other, not both. So if I put 0 here, actually, it could be both. I take it back. So this is going to be a combination. So you can be less than 0. Now, if it was greater than 4, you do this. And so it's a union. So the combination of those two. Not necessarily, when I say combination, I want to be clear about that. Not intersection, not what's common, but just like stating the whole thing, the union. Now, of course, x is less than 4. So in essence, actually just be that. And the 0 be included as well. Because it's a union of it. And one way you could think of it, you probably might have learned this back in the day. Say this is set A. Say this is set B. So if you want A and B, what's in both A and B? That has to be 1. If you want A or B, or it could be both. And it's a combination of all that. So 1, 2, 3, 4, 5, 6. And sometimes you'll see the and situation like this. That's intersection. And the or situation would be kind of like this, where the U stands for a union. And that's going to be a union. So even those that are common are part of, you include as well. And of course, everything else that's unique to A or B. For 4, you're being asked to write compound inequalities. This should be pretty easy. X is less than -2 or x is greater than 5. It can't be both. It's one or the other. But once in between, you're going to say and. So like in this case, you'll say -2 is less than or equal to x, which is less than 5. Or you could write it x is greater than or equal to -2 and x is less than 5, because it has to be both. It has to satisfy both of those situations. Solving should be pretty straightforward. So if I do 5a, you'll move, let's say move the 6x to the left side. So you have 2x plus 3 less than or equal to -5, -2x less than or equal to -8. And whenever you divide by a negative, you have to flip the inequality. The reason why you do that is you have to guarantee the same result if you decide to move the 4x from left to right. So if you isolate x on a different side of the inequality, you'd have this, then add the 5, then divide the 2. And of course, if I put 0 here, 1, 2, 3, 4, filled in, go to the right. So we'll do 5b and 6 as a class next time. Looking at 7, I think we'll save that for next time as well, and 8. Word problem we'll save for next time. Okay, 1.7 is about absolute value equations and inequalities. Absolute value is defined as a distance from 0 on a number line. So if you have 0 and you have 6, 6 is clearly 6 away, so the answer is 6. But if you have absolute value of 5 minus -11, absolute -6 is 6, because it's still the positive distance from 0 on a number line. So that's the definition of it. Positive distance from 0 on a number line. So for C, that'd be x equals 10 or -10, because both those answers would be 10 away from 0 on a number line. For D, so y minus 7 itself could equal 10, or it could equal -10. So that expression could hold two values. And we'll talk about E next time as a class and solve D. I mean, it's pretty obvious that D is going to be y equals 17 and y equals -3. So it's two answers it holds. What the heck, let's do E for closure. So 5x minus 10 equals 45. 5x minus 10 equals -45. So 5x equals 55. X is 11. 5x equals -35. X equals -7. Let's not worry about 2 for now. We'll talk about number 3 later. And we'll talk about 4a and b another time as well. Those 5 and 6. Inequalities. So clear x has got to be more than 6, or x could be less than or equal to -6. Because what if x were -7? The absolute -7 is 7, which is greater than or equal to 6. And on a number line, it would look like this: 0, 6, -6, filled in because they're less than or equal to or greater than or equal to. And you shade to the left of -6 or to the right of 6. So you have to be mindful that if it's greater, it's going to hold, there's two separate inequalities, and it's an or situation because one or the other is bigger than 6 or less than or equal to -6. It's not going to be simultaneously both, because you can't simultaneously be greater than 6 and less than -6, right? It just can't happen. For a less than situation, of course x is less than 6. But it can't be too low, like you can't make it -7, because -7, the absolute value of it is not less than 6, right? It's actually bigger than 6. That can't happen. So you also have to guarantee to catch it from going too low, and there's equal as well, that it's also greater than or equal to -6, or and greater than or equal to -6. So on a number line, it would look like this. Or first, we write a compound inequality like that. It's sandwiched in between the two. Here's 0 in the middle, and included any shade in between. So I like to think of the and situation as sandwiched. Kind of play on words there. The or situation, when it's like x is greater than 6 or x is less than 6, sorry, less than -6. We had equals, let's do equals. It's like two oars on a rowboat, if that helps. So a little bit of play on words there. We'll talk about next time in class. And that concludes the video for 1617. Kind of gives you an overview, does some of the notes. We'll fill in the blanks when we meet again. And that's that.